So in this session, we are discussing healthcare data engineering project as part of AWS data engineering real-time projects. So what we are doing, we are going to do patient risk and cost analytics pipeline with AWS S3 and AWS Glue and AWS Redshift. So first, as a user, we are going to upload patients data patients underscore data dot CSV file in AWS S3. Then we will write AWS Glue. We'll write AWS Glue. We will write, yeah, yeah. So first, as a user, we are going to upload file into patients underscore data dot CSV file in AWS S3. Then we are going to write a AWS Glue job, AWS Glue job. And in this AWS Glue job, first we will create a data frame. We'll create a data frame by reading this file. By reading this file, we'll create a data frame. We'll create a uh, read CSV, read CSV, then and apply transformations and and results persist into persist into AWS Redshift. Okay. So what kind of analytics we are going to do here? We are going to do these two, risk, patient risk and cost analytics using our analysis. In AWS Glue, we are doing these analytics. Okay. Once we complete analytics, we are going to persist this results into Redshift. AWS Redshift. That's why this one is AWS Redshift. So in this AWS Redshift, we are going to create a table. Okay. In that table, we are going to write data. And this table become input to our downstreams, our consumers. So this one become input to consumers. Yeah, yeah, sure, definitely. Once again, I'll explain. So here, our downstreams are data analyst, data analysts, like may uses Power BI, or tablet, or QuickSight, QuickSight. etc. ML people, AI people are consumers to our data, Redshift data. Let me explain here. So first one, we do ETL operations here using AWS tool. We are doing ETL operations. ETL operations. We are from extracting data from S3, then transforming data using AWS tool, then finally loading means persisting data into Redshift. Persisting data into Redshift. Here, once transformations are completed, we are going to persist the data into AWS Redshift. Here we use JDBC connection tool. Here we use JDBC connection. We will create a connection between AWS tool and Redshift using JDBC, and we will write data into target table. This table become input to these consumers. So this table become input to consumers like data analyst people. They uses this table. They prepare reports or dashboards. If it is ML AI, these people applies feature predictions on this table. So this part we are going to do as part of our today's use case. We are going to implement this entire part up to this part. Uploading data into S3, writing glue job, writing data into AWS Redshift. Okay. Yeah. Let me take this diagram. Yeah. Clear writing. What kind of activity we are going to do as part of this healthcare data engineering project? Okay. So whatever I explained here, same thing I explained in this project description. This project demonstrates how to build real-world healthcare data engineering pipeline using modern AWS data engineering services to analyze patients' data and generate actionable insights. Okay. Here we are going to use AWS S3, AWS Glue, and AWS Redshift. Three services we are going to use as part of this project. Okay. Let me show you practical step by step. So we are covering as part of this one, we are covering these concepts in our scenario to high risk patient identification. So in this total input data, this is my input data. So from input data, what I'm going to do, I'm going to find who is high risk patient. We identify high risk patients, and we are going to readmission risk detection. Next one, treatment cost analysis. Then city-wise health trends and disease-based insights. So these kind of activities we are going to implement as part of our AWS Glue, AWS S3, AWS Redshift as part of healthcare data engineering project. Okay, let's start implementing. First step, step one, upload the data into AWS S3. Upload the data into AWS S3. First, important point here, re- requirements. Requirements. First requirement, you need to have AWS account, AWS account, and knowledge on AWS S3, AWS P2, and AWS Redshift. AWS Redshift. So you need to have AWS account and then AWS S3, AWS Blue, and AWS Redshift knowledge. Okay, let's see practical implementation. First, let's open a new browser. I'm opening Google Chrome. Okay, and start AWS start Amazon.com. Then log into AWS Cloud. Yeah, I logged into AWS account. Let's open AWS S3. Okay, let's open AWS View. Let's open Amazon Redshift. Okay, I opened these three services. First, I'm creating a bucket, S3 bucket. So S3 bucket name I'm creating with this name, AWS TV Healthcare Icon project. Under that, I'm creating folder called RA. Let's create a bucket. Create a bucket. Bucket name is this one. AWS TE hyphen healthcare hyphen project. Then here uncheck this block access. Accept I acknowledge. Then click on create a bucket. In this bucket, create a folder called RA. Create a folder RA. Then create folder. In this RA folder, upload this patient data.csv. In that raw folder, create another folder called patient underscore data. So create a folder, patient underscore data. Okay. And then create a folder. In this patient underscore data folder, upload this patient data.csv. Let me open patient data.csv. Let's create a file. Let's save this file under my C drive, under datasets, under AWS project. I'm creating this file with patients underscore data.csv. Let's take this data. It has both header and rows. The CSV file contains header and data. Okay, let's save this one. Now, let's upload this file into my AWS S3 location. Let's open datasets folder. Click on datasets. Click on AWS project. Then patients patient underscore data dot CSV. Let's drag and drop this file. Then click on upload. Click on upload. First part is completed. Yeah, first part is completed. Once the data is uploaded into AWS S3, then create a blue data catalog, create a table. So what I'm doing, I am going to create one step here, additional step, step, step two, create a crawler, create a crawler, and create a table, create a metadata table, metadata table, and write, write AWS Athena, Athena, AWS Athena queries, queries to validate or verify, verify the S3 data. Once we load data into AWS S3, we do these kind of activities too. Okay. So first step, once we upload data into S3 and we do this activity. Okay, let's create it. Yeah, I'm explaining here. So here, first we need to create a data catalog. uh, Data catalog. Here we have databases. We need to create one database to store the metadata information about your input data. So first I'm creating one database, add a database. Database name is, let's say, health care underscore DB database name. Then create a database. Then here you can see one option in AWS Glue called the crawler. What this crawler is going to do is, crawler, we give a input to S3 file. For crawler, we give input S3 file. This crawler reads S3 file, identifies this header, identifies this header, and it will create a table in AWS Glue data catalog by storing these column names. Plus, it reads the sample data. It reads this sample data and identifies each column data type, and stores column name and data type, column name and data type in AWS Glue data catalog. Okay. So here, create a crawler, and here give a crawler name, healthcare underscore crawler. Okay. Now healthcare underscore crawler. Now let's click on next button. Click on add data source. Select the your input file location. Click on browse. Here in AWS healthcare project, we have raw. Under raw, we have patient underscore data. In this location, we have CSV file. Don't select until CSV file. Uh, Select only until the folder of that CSV file. Then click on choose. Then click on add S3. Then click on next button. Here we need to attach a IAM role thing. So I am creating a IAM role. For this IAM role, I am giving name is healthcare. Healthcare. Click on create. Then click on next button. Click on select the database. Database name is healthcare underscore DB. Then click on next button. Click on create crawler. Okay. So go to databases. Go to healthcare DB. Currently, there is no table. Tables are zero tables, right? So go to crawlers, refresh. You can see healthcare crawler. Select this crawler, click on run. It will take few minutes time. It will connect to S3 and it will read the data. It may fail due to IAM issue. So click on IAM, click on roles, click on roles, and here select healthcare, click on this healthcare and attach S3 full policy, S3 full permission, as well as we also need we also need Redshift full permission, Redshift full permission. Attach this permission onto this role. We are going to use this role in AWS Glue also too. Okay. So go to crawler. Still it is running. Let's wait a few more seconds to complete this one. Yeah. Crawler is completed. It is stopping. Go to databases. Go to healthcare DB. You can see one table, patient underscore data. And this is S3 part, S3 part. Then click on patient underscore data. You can see column names. Patient ID is diagnosis, cost, city, admission date, readmission. So whatever you mentioned here, these columns it identified. Based on header row, it persisted column name, it identified data types of each column is correct. It stores only metadata information. Okay, now I want to write a SQL query on top of S3 file system data. I want to write SQL query on S3 file system data to verify data is loaded properly or not. So for that, there is one service called Athena. Let's open Athena. Athena in a new tab. Okay. In this Athena, first select a database. Which database we want to write queries? Healthcare. Select healthcare DB. And in that we have one table name, patient underscore data. Then write select star from patient, patient underscore data. Let's see the data. So you can execute SQL query. So total 20 records. Okay. So total, how many records? One header and 20 rows. SRE. So it loaded all the rows into S3 file system. By seeing this, by writing this SQL query, we can confirm data is loaded properly. If you want to do any additional queries, you can write here in Athena to verify your data. Okay. So once this step is completed, then step 3. Let me show you. I return this SQL query. Yeah. Redshift is data warehouse. Yeah. No. Athena, we run on top of S3 file system. Yeah, for that, to pull data from Redshift, we use this one, AWS P. Okay. So now let's write a AWS Blue job to implement the transformations. We have data in S3. Now I am going to write AWS Blue job to read this data, apply transformations, and going to write into Redshift. And Redshift, you should create a Redshift to cluster. I already created Redshift. Let me click on query editor. Okay. So this is my Redshift UI access. Let me create a new. Hmm. Sure, sure. Definitely, definitely I will. No worries. It's a data warehouse. Yeah, it supports multiple formats. It also supports, but we use different techniques to store the data. Yeah, structured only. Okay, here I already connected Redshift using Query Editor. Query Editor is a client software, comes by default with AWS Redshift. In AWS Redshift, you have a Query Editor. Once you click on Query Editor, it shows this home page. Here we write SQL queries to it. Okay. So first, let's go to our blue, and here we are going to write blue job. So we are going to write a blue job. In this blue job, first we are going to read the data. We are going to read the data from S3. Then we perform cleansing the data. If any null values, if any data type mismatches, we do cleansing operation. Then we write transformations using blue job. Then finally, we are going to generate insights means results. Then finally, we write output into silver layer of Redshift. Okay, let's do this activity. So I'm creating a blue script. Blue script name is patient's data analysis. Patient's data ETL. Let's create patients underscore data underscore ETL data py. Okay. ETL data py or ETL. Okay. Let's take this program name. Go to AWS Glue. In AWS Glue, we have a concept called ETL jobs. Click on ETL jobs. Here we have a visual ETL. Click on visual ETL. Then here we give a job name. And this ETL job, yeah, tell me. In this ETL job, we are writing this ETL job. This ETL job going to read AWS S3, AWS S3, and it is going to use AWS Redshift, AWS Redshift. Okay, so so this job, this job, ETL job, this ETL job need permission of S3, need permission of Redshift, need permission of Redshift. Okay, so using IAM, role. We just now created I am role, right? For that I am role, we attached S3 permission, we attached Redshift permission, right? Then we are going to attach this role to ETL job. Let's see how we are going to attach this role to ETL job. Let's click on job details. Here we have I am role. Click on I am role. Search healthcare. Select this healthcare role. Then once you attach this role, this patients underscore data underscore ETL dot py file having permission of S3, having permission of Redshift. Then language we are selecting. Yep, we can create in advance or while performing crawler, we created a IAM role. But later we attached after creating role, we attached these two permissions, Redshift permission, S3 permission. For this IAM role. Yeah, first let me create a program, this program, and then here we selected a Python language. Here by default it using number of workers are 10. Then for my requirement, I'm just using 2 workers because if I use 10 workers, it will cost. So I'm reducing number of workers to 2. Then click save. Click on save. Now go to script. Here you can see script file is generated. Click on edit script. Click on confirm script. Okay. Here we are going to add our script file. Okay. Let's see. This is the script. Let me go to ETL script. So in this stream, first what I'm doing, I'm reading S3 file. I'm reading S3 file under AWS TV, under healthcare, under project, under raw, under patients underscore data. We have a input path using spark dot read dot option. Here I'm saying my input file contain header. So then my input file type is CSV. Then I'm passing this one to spark.read.csv function. It will read file from specified location and creates a data frame. Creates a data frame. Once it completes creating data frame, I am applying data cleansing operation. First one, creating data frame. Second operation, data cleansing operation. In this data cleansing operation, what I'm doing, I'm reading columns. I'm reading column names. In this column names, data I'm converting into lower. And after that, what I'm doing, I am removing null values. So if any of these columns contain null values, I'm removing entire row from that input. Let me open in my file, my input data. There is no null value. So you cannot see data removed from this one. Next one, I am performing cast type. So age column, I am converting into integer type. Cost column, I am converting into double type. Then I am creating new column with column admission date. This admission date I am converting into data type. I am performing data type changes. Next one, what I am doing, I am performing standardized text. Means here, there is a column diagnosis. There is a column diagnosis. Okay. 1, 2, 3. So diabetes, heart disease, fever, cancer. So this is related column diabetes. In that column, what I'm doing, if any spaces before this value, before this value, after this value. I'm just trimming that spaces, trimming spaces, because I'm going to search a disease, because we are going to perform disease based solution also, right? We are finding, we are applying here. If you observe here, we are finding disease based insights. When you search particular disease, if you are passing a value, but in input file, it may contain space before or after, then it will not match. So to resolve that problem, what I am doing, I am performing trim operation, trim operation too. Okay, trim operation. And next one with column city. Here city column, I am converting into uppercase. Then finally, I am applying transformations. Transformations, first I am finding risk category. I want to identify a patient who comes under risk category. So I am creating one column called risk category column. If you see, there is no column risk category. There is no column risk category. Using glue, I am creating one column called risk category. Then I'm checking column age greater than 65 and diagnosis is heart disease or cancer. Then I'm saying risk categories high. Again, I'm checking that when diagnosis equal to diabetes, risk category is medium. Otherwise, risk category is low. I am creating a new column. I am finding risk category of each patient, high, medium, and low based on different conditions. Then other one, cost bucket. I am finding cost too. So data frame dot with column, I am creating a new column called cost underscore bucket when cost greater than 70,000. If you see here, you are seeing cost column. Here you can see different values. Then based on the patient paid charges, here we are finding uh, cost is high, medium, or low. Another column we are creating. In that column, we are finding high, medium, or low cost. And third one, readmission risk. Let's say I am finding who readmitted equal to yes. And I'm going to check whether that person is greater than 60. If person readmitted with age greater than 60 means it is high risk profile. High risk profile. Otherwise, it is low risk profile. We are creating a readmission risk column. Then we are adding values by applying these conditions. Okay. Next, partition column. Oh, yeah. Otherwise, it acts as a else. No, no. We will get this criteria from our client. We are implementing. Hmm. Initially said what we are doing, business scenarios. Okay. Now, now let's say another one, partition column. So year column is a partition column from admission day, from this admission day, I am taking year column and I am creating partition based on year column and month column. So from this admission date, I am finding year, I am finding month column. Then I'm creating new columns called year and month. Then finally, I'm creating one more column called ingestion time. Then I'm uh, getting current date, each record. When you write into Redshift, right, I am ingesting current timestamp of insert date. Then finally, I am writing output into this S3 location. So first I am writing S3 location, or you can directly write into Redshift location. Okay. Okay. Write into Redshift. Let's say, sure, sure. Before that, let me add one point. Let's say you are a Snowflake developer. You are a Snowflake developer, or you are a Redshift developer. Same kind of Snowflake, what we do, right? Same thing. Redshift developers also do. We have lot of openings for Redshift administrators and Redshift developers. Similar to Snowflake, this is also a cloud data warehouse, which also supports unlimited storages. So here, our main intention of adding Snowflake people in this project is, let's say you are a Snowflake developer, understand how data engineers here, which data engineer is working? AWS data engineer. AWS data engineer, how he is connecting input and how he is writing transformations using Glue, using Glue, how he is writing transformations, and how he is finally writing data into Redshift. Or tomorrow we are going to see Snowflake. How AWS data engineer writing transformations on the input data and writing output into Redshift. Similar way, if you are a Snowflake developer, we have DBT. Whatever transformations they did using this logic, whatever transformation logic we see here, so many transformations we see here, right? Risk category, cost bucket, and readmission risk, patient partition column, metadata, and finally, we are going to do these kind of activities using either DBT or Snowpark or Snowflake SQL. And this data ingestion from S3 to Snowflake, we do data ingestion using Snowflake stages plus copy command. Snowflake, Snowpile, stages, and copy command. We load the data into Snowflake table, then we apply similar kind of transformations using DBT or Snowpark. Clear writing, Snowflake people? Yeah. Now let me explain where our Athena fit into this diagram. So once we loaded data into S3, here we are creating Athena for Athena. Once user is loaded into S3, here we are writing Athena. Athena. Yeah. Yeah. Snowflake schema is it supports. Yeah. Yeah. Here we write SQL queries to verify data loaded properly or not on this S3 file system. This is the file system. Yes, correct. Once data is loaded, we are creating a group ladder. We are creating crawler. This crawler reads this data. Crawler reads this file and creating metadata. Metadata in a glue data catalog. Glue data catalog, which is creating metadata with column names and data types. Then when you are writing SQL query means it is going to refer this blue data catalog. Then it will read this data and displays for us output. Athena specially designed for reading data of S3, not for Redshift. We can also connect Athena to read data from Redshift. That is difficult to process. We need to do. But Redshift, we have a SQL queries, right? We can write SQL queries and Redshift. Then we can do unit testing. Once the data is loaded into Redshift, we do not require help of Athena. Redshift itself is supporting SQL. Hmm. Hmm. No, no. These based on this sample data. Based on this sample data, it identified data types. Yeah. If you see this table, uh, open databases and healthcare data. This is our table. You are saying these data types, right? These data types are Athena data types. String, begin, string. Yeah, different technologies having same data type, Java and other technologies. So these are Athena data types. No, no. Blue transformation, no, we created complete script based. Yeah, script based only. Yeah, that's it for today. Team. We have a AWS data engineering uh, new batch at 6 a.m. IST from Wednesday. We are starting a new batch, AWS data engineering. Who do not have AWS data engineering? We are starting new batch 6 a.m. IST. Who are interested, contact Kalyan. Tomorrow we are going to discuss instead of Redshift, we are going to replace with Snowflake. Snowflake. How AWS data engineer interact with the Snowflake for writing output results. Okay. So tomorrow session is AWS data engineering integration with the Snowflake, and we have a new batch of Snowflake Monday onwards from 8 p.m. IST. Who are interested? Sure. Data engine. No, no. RDS is related to databases. This is data warehouse. RDS full form is relational database service. In RDS, we have MySQL, PostgreSQL, MariaDB, Oracle, IBM DB2, and Microsoft SQL Server. AW, sure. Yeah, tell me. EMR, instead of this AWS Glue, you can use a EMR for ETL operations. Whatever logic we written, right? We can replace with AWS Glue with EMR. The problem with EMR is we have to create a fixed cluster. Example, we created a AWS EMR cluster with 256 machines, but we are getting data max of 1 GB to 10 GB. But we pay rent to 256 machines. Assume we reduced 256 machines to 10 machines, but we got to 10 TB data. Then it is not possible to process that huge volumes of data with a small cluster. So that is the problem with EMR. EMR is a fixed cluster. But coming to Glue, Glue is a serverless. It will scale automatically, min and max resources. Min you can specify, let's say 2. Max you can specify 256. Depends upon your input data, it will scale automatically. It is not a fixed cluster like EMR. That's what both are for implementing ETL operations. In AWS EMR also we write a PySpark code. AWS Glue also we write a PySpark code. Databricks also we write a PySpark code. Okay, yeah, that's it for today, team. And contact AWS data engineering courses and Snowflake data engineering courses. Contact Kalyan. Kalyan already provided syllabus and Kalyan also given numbers here. He is going to share. Kalyan. Yeah, you can contact Kalyan for AWS data engineering and Snowflake data engineering team. Yeah, that's it for today, team. Tomorrow we are going to discuss AWS Glue integration with Snowflake, same time, team. Yeah, that's it for today, team. Yeah, thank you all.